Boom. Hello and welcome back to Calculus 1, section 4.9, the antiderivatives. I.e., let's undo the derivatives. And the popular name for this is actually integral. So we're going to learn the notation and the most basic integration there is. And then we are going to upgrade and give meaning to all of that stuff in the next chapter, which will start next class. So, you are familiar with the fact that if you add two numbers, you can undo that operation by using subtraction. Same thing goes for multiplication and division and so on. So each one of the operations that are used in between numbers has its operation that it's technically opposite of it. So now when we move to the world of operators, and operators change functions, where operations change numbers. So when we change to operators, some of the examples of operators are derivatives and integrals, and they are in opposition to one another. So I will not be teaching much of the new stuff here, other than notation and some aspects of that. I will be mainly focusing on, obviously, just reading the derivative charts backwards, because that's what this stuff is. Let me show some of the examples. So we know that the derivative of x squared is 2x. So now I'm going to use this new notation for what we call integrals to say that the integral of 2x dx is equal to x squared, because this is supposed to undo. So what I have is I have this pair, right, x dx like this, and then I get to plug something in here. So both of these are important to write, integral in front and dx at the end. Now we will see when we talk about the meaning and importance of these things, what all of these things mean. Right now you are just learning the notation. Now there is more to this stuff. The derivative of x squared plus 10 is how much? Also 2x. So that means that the integral of 2x dx is equal to x squared. And do you already see an issue over here? Missing information. Very good. So it kind of worked for the first one, but it didn't work for the second one. And even if you come up with whatever else, so d dx of, let's say, x squared minus 6, it's still going to be 2x, and integral of 2x dx is going to return x squared only. Which is the reason, right, we can't extract these numbers. This is the reason why we put plus c every time we integrate. So it's not there for decoration. This plus c states that there is some unknown constant that could have been there that was completely destroyed by the derivative. So derivatives destroy this piece of information, and then when you do the integration to go back, you don't have the way to, well, there is a way, but you need some extra information to actually figure out whether it's nothing there or plus 10 or minus 6 or whatever else. So anytime you do the integral, you have to put plus c. I don't see you writing that down, but it's -1 per problem. 10 integral problems is minus 10 problems, so minus 10 points. So you see that. So every time you integrate, you put plus c at the end. So you either put plus c or -1, whatever. It's a choice. Okay. Now, the rest of the section, most of the other stuff you should pretty much know. What is the integral of cosine x dx? What would you say? So your question is, so what goes in this box plus c? This is what you should ask yourselves. The derivative of what gives me cosine x? Sine x. The problem is that you guys said negative sine x, so I said So derivative of cosine is negative sine. Integral of cosine is positive sine. Woohoo! Way to confuse things, huh? So that's that. So everything that you know from the chart of derivatives stays the same except one formula for polynomials. Okay? So let's write some of these formulas down. Integral of the constant k dx is going to be kx plus constant c. So integral of 3 is 3x plus c. Integral of pi is pi x plus c. So whatever constant you have, if you're integrating only a constant, you are going to get kx plus c. Here is the one that you don't have, and this is for polynomials. Integral of x to the n dx is x to the n plus 1 divided by n plus 1, everything plus c. You remember how for your derivatives you did n minus 1? Well, it should make sense that for integration it goes plus 1 because it's opposite. It's supposed to undo it. So derivative of x to the 4th is 4x cubed. Integral of x cubed better be some kind of x to the 4th, which is x to the 4th over 4. So that's that. Integral of e to the ax dx, remember? E to the 2x, e to the 7x, e to the negative 5x, is going to be, you copy e to the ax and you divide it by a, plus c. We have 6 trigonometric ones. Now remember how the derivatives were of sine and cosine and secant and tangent, right? You're not going to get that here. Because remember what the backwards are. To do the base trig integration, you will be integrating sine, you will be integrating cosine, but then you will be integrating secant and cosecant squared, and you will be integrating secant times tangent and cosecant times tangent. Those are the ones you are working on. So let's write them all out. The integral of sine x dx is negative cosine x plus c. Integral of cosine x dx is positive sine x plus c. Integral of secant squared x dx is equal to tangent x plus c. Integral of cosecant squared x dx is negative cotangent x plus c. Integral of secant x tangent x dx is secant x plus c. And finally, integral of cosecant x cotangent x dx is equal to cosecant x plus c. So as you can see, these are not basic ones as tangent and secant and cosecant, right? This is literally the chart you have for derivatives backwards. You see all 6 basic trig ones, right? Now, we are going to cover some more in chapter 5, but for the main part, this is it. And then when you go to Calc 2, you are going to have a whole section on trig integration, then another section on substitution using trig. It's called trig substitution, trigonometric substitution. Yeah. So there will be a lot more of this coming up. I want to write a few of the rules so that we understand that as well. Rules. Integral of a constant k times a function dx, you can kick constant k outside. I like this blue, it's too... Can you see this blue? Oh, I'll put plus c dx. This rule simply says, just like a rule in limits and derivatives, that if you have a constant times the function, you can kick the constant outside in front of the integral. We did that for limits, we did that for derivatives, and here it is still with us in integrals as well. The next rule says that if you have multiple terms added and subtracted, you can integrate individually. So integral of f of x plus or minus g of x, whether it's addition or subtraction, is integral of f of x dx plus minus the integral of g of x dx. So you get to do them separately. And those are the rules. Let's apply some of this stuff. Say you are supposed to integrate 3x squared plus e to the 6x dx. What you can do, I mean, clearly by the end of Calc 1 you will be just looking at this and mentally writing the solution right over the way. But now let's just separate everything and use the rules. So first of all, I know I can have 2 integrals because I have plus in the middle. First integral on 3x squared, but 3 is a constant, so I can kick that in front of the integral. So this is 3 integral of x squared dx plus another integral of e to the 6x dx. So my first step was, again, you'll be doing this mentally eventually, but now just separating the 2 integrals. So now I have 3 times, and we have the formula for polynomials, which is x to the n plus 1 over n plus 1. So that's going to be x cubed over 3 when I integrate, plus, and we said for e to the exponent, you copy e as is, and you divide by 6, right? That's the ax part. And you have to put plus c at the end. These 3's will cancel. So the final answer over here, all cleaned up and nice, is going to be x cubed plus 1 over 6e to the 6x plus c. You can also write e to the x over 6, whatever. I mean e to the 6x over 6. So this problem outlined many features over here. We had the integral of a polynomial, integral of the exponential function, and we also separated using the rule. Anytime you have addition and subtraction, each one is done independently from the other. and you preserve the sign, so if it's a plus, it's a plus, if it's a minus, it's a minus. And at the end, we also had to kick the constant outside because we can. And later that constant canceled, but it's right there. It helps to rewrite things, to put them in the form of what you know. What is the integral of square root of x dx? What do you think? What should we do to solve this problem? Anyone? Very good. X to the 1/2. And then we have a formula which deals with x to whatever half or whatever exponent you have. Now it's 1/2. It could be 3, it could be 7, whatever it is. So we are going to rewrite the integral first as x to the 1/2 dx. And then we are going to use integral of x to the n dx is x to the n plus 1 over n plus 1 plus c or minus 1. So my exponent for x is plus 1, so I have x to the 3/2 divided by the 3/2 plus c, which is 2/3 x to the 3/2 plus c, and we walk away. So we rewrite the problem first, and then we just look at the exponent and say, okay, this is what it is. So just try not to confuse the polynomials with exponentials and so on. But if you follow the prescribed right path, you should not have any issues. Let's pick up some examples from the book. By the way, lesson is over. I just need to do a few more examples. Many more examples, actually, over sections. But so what is the integral of 6 divided by x to the 3 dx? As I wait for book to load. Should be this here at some point. Okay, that was enough time. So what we do is we write this as 6 times x to the minus 3 dx. We can kick 6 in front of the integral. And now we are going to use the same formula from above. 6 times x to the minus 2 over minus 2, because you're adding plus 1 plus c. And now this becomes negative 3 times x to the minus 2 plus c. And the total is negative 3 over x squared plus c. Now the idea is to go from start to finish in one step by the end of Calculus 1. Let's see what else would be good. So integral of 4 cosine x minus 4th root of x dx. So we have integral, kick 4 outside, cosine x dx, that's the first integral, minus integral of x to the 1/4 dx. So we have two integrals, we preserve the negative in between them, kick the constants outside, change the 4th root into 1/4 exponent, and then plow through integration. Copy the constant 4. Derivative integral of cosine is positive sine, very good. So just sine x minus, and now we have x to the 1/4 plus 1, that's 5/4, divided by 5/4 plus c. The only thing you can do here is write this as 4 over 5 times x to the 5/4 plus c. You don't have to factor 4, doesn't matter. So that's that. We are not going to be setting this equal to 0 and so on. The last skill is to understand the procedure to obtain this c. So way to compute c. I have to give you integral, and I also have to give you something that is called initial condition. And you will be able to retrieve c if I give you initial condition. So here's what's happening. Remember when I said that the integral of 2x dx was equal to x squared plus c? If you recall from your pre-calculus, this plus c is shifting function up and down. So depending on what the value of c is, your graph, which is just x squared parabola, is going to be somewhere on the graph. So what I get to graph over here is infinitely many of these parabolas. So this is what I have. Now, if I give you a point in space, only one parabola will go through that point. And that's how we compute plus c. So let me say, find c given f of x is, let's say, 2x cubed. And the point is, I don't know, 1 and 6. It doesn't matter. So what do? We integrate 2x cubed dx. We know to kick 2 outside and then just integrate x cubed by adding 1. So we have 2 x to the 4 over 4 plus c, which is further equal to 1/2 x to the 4 plus c. Right? Now, what do you do? So this would be the answer, but I want what we call a particular solution. So what I do is I take this, and I also have 1 and 6. So you know that this is x and this is y, right? And this is a function. So you will set everything equal to 6. You have 1/2, and then you have 1 to the 4th power plus c. So all I did is I plug in x equals 1, y equal to 6. Very simple. I get the equation below, and this equation contains only one variable, and that's variable c. So now you have a 6 is equal to 1/2 plus c, from where c is equal to 5.5. So now your particular solution, we call this the antiderivative capital F of x, is going to be 1/2 x to the 4th plus, well, we can go 11/2, right? It's better. If I do 11/2 is nicer for math. 11/2. The one thing that I really love about integration, and I love it since I'm a student, you can check it. See, for derivatives, you take the derivative and you say, hey, I hope it's good, right? And you walk away. And then shiver over the weekend until you get the test back. For the integrals, guys, all you need to do is to take the derivative of your answer. If you get this, you're 100% okay. If you don't get that, it's definitely wrong. And this is why I loved integration. The chapters 5, 6, and 7 for me were the best thing ever. So, usually I do it in green. So, we're just going to do the check for this problem and we're done. Check. You should do this for every problem. And literally, we just walk up and say, put the 100 over here. Because that's exactly what's happening. We take the derivative of 1/2 x to the 4th plus 11 halves, hoping to get 2x cubed. If we get anything but 2x cubed, the whole thing is wrong. Let's go. To find the derivative, we copy the constant. We take the derivative, which gives us 4x cubed plus 0. 4 and 2 will cancel. Get 2x cubed plus 0 is 2x cubed. We got exactly 2x cubed, and we know that this is good. And that's the end of 4.9. You just need to do 1,000 examples, and we'll continue talking about the integration next class in chapter 5. See you all.